Today we're going to learn about something called synthetic substitution and division. This is taught in two different sections of the book, but it's the same process and procedure, so I put it together in one lesson. The word synthetic, when you hear synthetic, what does that mean? Fake. Synthetic means fake. When we talk about like synthetic fibers, they're man-made fibers. So it's not like wool or something that comes from an animal. It's something that was made in a factory to kind of maybe mimic what wool might feel like. But synthetic means fake. So synthetic substitution and synthetic division are like fake ways of doing things, or kind of shortcut ways. So to evaluate an expression, so if we're given this equation and we're asked to evaluate it when x equals 3, one way to do that is to just go and plug in 3. So 2 times 3 to the 4 minus 8 times 3 squared plus 5 times 3 minus 7. And that'll give us an answer to evaluating it. We have some very large arithmetic to do in that process because we got 3 to the 4th, which is 81. Then I have to multiply that by 2. And then I have to subtract more stuff with powers. And the arithmetic becomes very large. Okay? So we have this other way that's called synthetic substitution, which is like fake substitution of doing it. Our first step is to write out all the coefficients in a row in standard form, which means highest power of x on down to lowest power of x. And if there's any missing terms, we have to put a 0 in for a placeholder there. Then we're going to write the x value that we're going to substitute in the little box off to the left-hand side. And then our process is going to be to carry down, multiply, add. Multiply, add, multiply, add, multiply, add. So those last couple of steps get repeated. So I need some space here to do this. No. All right, so our equation was f of x is 2x to the 4th minus 8x squared plus 5x minus 7, and we're letting x be equal to 3. All right, so there's a little bit of space there under where it says step 5 in your notes, and that's probably where you would want to do this. So what we're going to do is start with our highest power of x and then count our way down to a constant. So x to the 4th, x cubed, x squared, x, constant. Underneath those, we're going to write their coefficients. A coefficient is the number that's in front of it, making sure that we bring negatives along. So with x to the 4th, there's a 2. There are no x cubed terms, so we're going to put a 0 there. It is important that we have that 0. Okay? We will get a wrong answer if we're missing our 0 terms. For the x squared, we have a negative 8. For the x, we have a 5, and for our constant, we have a negative 7. Okay, so that's our first step, is to write all the coefficients in a row, counting down from our highest power of x in the problem down to the lowest power, including zeros if anything's missing.
Where did the x cubed come from?
Because there isn't an x cubed in the problem, we have 0 x cubes. So we're just counting down all the powers, making sure that everyone is represented. Step 2 says to write the x value we're going to substitute off to the left in a little box. So that 3 that we're plugging in, I'm going to put over here to the side. Then I'm going to leave a blank row and make a long line. So if you're doing this on notebook paper, you'd skip one line here. Step 3 says carry down the first digit. So we're going to take that 2 and carry it down. Then we are going to multiply that 2 by the 3 that's in the box. So 2 times 3 is 6, and that goes in our next available spot, which is right underneath that 0. Then we are going to add down the column. So 0 plus 6 is 6. Now we repeat. 6, that last answer we got, times the number in the box. So 6 times 3 is 18, and that goes in our next available spot. Then we add down the column. Negative 8 plus 18 is 10. Then we repeat. 10, our last answer, times the number in the box. 10 times 3 is 30. Add down the column. 30 and 5 make 35.
How did you get the 8 and 18?
The negative 8 was there. That's our coefficient. The 18 came from the 6 at the bottom times the 3 in the box. Anything that's under that line, we multiply up by the box.
Okay.
And that gives us our next value. So now our last number there is 35. That's under the line, so we're going to multiply that up by what's in the box. So 35 times 3 is 105. And we add that now down the column and get 98. That last number is our answer. That's the same thing that we would get if we just took from the beginning the 3 that was given and plugged it in for x, which makes you maybe say, why wouldn't we just do that? Because we're going to use this same system to solve equations, and you can't solve an equation by just plugging in a number because you wouldn't know what number to plug in. Okay, so understanding the system and process is important to where we're going from here. Okay. It's uncomfortable the first couple times that you see it, so I'm sure there are questions, but we're just going to go ahead and head into the next example and kind of keep practicing. And this is one of those things that this process gets more comfortable the more we practice it. So our next example gives us this function. First thing we do is look through there for the highest power of x, not necessarily the first one in the equation, but whatever the highest one is, and we're going to count down from there. So our highest one is x to the 5th, and then we count down to the 4th, to the 3rd, squared, first, and constant.
Where'd you get x to the 3rd?
We're just counting down. So we start with our highest power, and then we just count down. 5, 4, 3, 2, 1, constant. Every power of x has to be represented. Then underneath those, we write their coefficients from the problem. So underneath x to the 5th goes a 3. Underneath x to the 4th goes a -1. There are no x cubed, so we put a 0 there. No x squared, so we put a 0 there. -5 x's and 10 constant. The zeros do make a difference, so we can't skip over them just because those terms were missing in the problem. Then we take what we're plugging in, which in this problem is a -2, and put it off to the side in a little box. We leave a blank line and draw our addition line there. To start the process, we carry down our first digit. Anything that's below this line gets multiplied by the number up in the box. So 3 times -2 is -6. And that goes in the next available space. Then we add down our columns. So -1 and -6 makes -7. Underneath the line, we multiply by the number in the box. So -7 times -2 is 14. Add down the column, 0 and 14 makes 14. Underneath the line, we multiply by what's in the box, -28. Add down the column, -28. Multiply by what's in the box gives 56. Add down the column gives 51. multiply by what's in the box gives negative 102. Add down the column gives negative 92. And that final number is our answer, which is the same thing that we would get by just taking the negative 2 and plugging it into the original problem. But the arithmetic typically stays smaller in this. So I like this process a lot because I'm not good with working with really large numbers. I'm not that good at arithmetic. So trying to plug that in and thinking about like negative 2 to the 5th power and multiplying that by 2, that can, or by 3, can get a little bit difficult for me arithmetic-wise, but the arithmetic typically stays smaller in the synthetic substitution. Okay. But again, even if you don't particularly like this process, it's going to be important to solving the equations that we're heading towards. Questions? Okay, our first step is to find the highest power of x, which may or may not be the first one there, but start with that one. So what's our highest power of x? X to the 5th. So even though it's not the first one there, we want the highest one. And then we count down to the 4th, to the 3rd, to the 2nd, to the 1st, and constant. Even if they are not all in the problem, they all need to be represented, starting from the highest power and then just counting on down. Then we attach their coefficients to them. So to the negative 5th is, or to the 5th is negative 5. No 4ths, no 3rds, 1x squared, no x's, 1 constant. The number we're plugging in goes off to the side in a little box. Blank line for space. Begin by carrying down the first number. Then anything under the line, we multiply by what's in the box and put in the next available space, and then add down the columns. Go ahead and work through this problem till a solution. All right, so we carry down that negative 5, and then we multiply anything underneath. So the negative 5 times negative 1 makes 5. Add down the column gives 5. Multiply by the box gives negative 5. Add down the column gives negative 5. Multiply by the box gives positive 5. Add gives 6. Multiply gives negative 6. Add gives negative 6. Multiply gives positive 6. Add gives a solution of 7. Okay. So that's the way synthetic substitution works. Now we're going to extend that idea to synthetic division. For synthetic division, there's a few theorems that come into play here. Again, the font looks all weird on here, but they're in your notes. The remainder theorem says if a polynomial f of x, so that's our equation, is divided by x minus some constant, then the remainder is r of the constant. It's what you get when you plug that constant in. Well, we just learned a new way to plug in numbers. Okay, so that's related there, that plugging in, the remainder theorem tells us, is actually a remainder from a division problem. The factor theorem says that if a polynomial has a factor of something, then it should have a remainder of 0. Factor means divides in evenly, which would mean no remainder. So what these say when we put them together is the remainder from division is the same thing you get when you plug in a number, okay? And the opposite of that number, and if the remainder is 0, then that thing is a factor. So to do division, it says write out the coefficients for synthetic substitution. So do what we were just doing. Then step 2 says write the opposite of the number that you are dividing by in the little box. Right? So instead of just being told to plug something in, we're being told to divide by something here. And what we want to do is think about what would make this equal to 0, and that's what's going to go in our little box. Okay? So off to the side, instead of putting, in the last problems it told us x equals something. Right? We knew what to put there. Here it doesn't tell us what x equals, it's telling us to divide by something. So we're going to take that and say if that equals 0, then what does x equal? And plug that off to the side. Then we're going to do the synthetic substitution. The quotient, it says then, is the numbers as coefficients. So that whole bottom row of numbers that we got is important here. They are going to be the coefficients of our answer. So let's get me a blank board, and we'll go through this example. So once again, there's some space at the bottom of that column in your notes. So we are told to divide this by x minus 2. So we're going to set up our coefficients for synthetic substitution. So when we did that, we looked for our highest power of x, which is x cubed. And then we count our way down. We write our coefficients, 1, 2, -6, and -9. Off to the side in the little box, we are not told in division what x equals. We're given an expression. So we're going to set that expression equal to 0. Find what x is, which will always just be the opposite of the number there. And that's what goes in the little box off to the side. Then we're going to do our synthetic substitution. So I carry down the 1, multiply gives 2, add down the column gives 4. Everything that's under the line we multiply. So multiply gives 8, add down the column gives 2. Multiply gives 4, add down the column gives -5. Now in substitution, that last number was the only thing that mattered. That was our answer. When we do division, every one of those numbers underneath the line matters. They are the coefficients to our solution. We begin with 1 less power than what we started with. So we started with an x cubed. Our answer will start with an x squared. And then we count our way down. So plus an x, plus a constant, plus this last number is our remainder. In elementary school, your teachers tell you when you have a remainder to just put an r in front of it. I really wish they wouldn't do that. That doesn't mean anything. A remainder is a part of a division. A part of a number is a fraction. So we want to make this a fraction, and for the bottom of that fraction, we put what we were dividing by.
That's the answer.
And that is our answer.
Okay.
This is called synthetic, and you probably don't want to write down what I'm going to do here. This is called synthetic because it is a fake way of doing long division. We could do long division with polynomials. Students don't even like long dividing numbers. So when we put long division in with letters, students really don't like it. But what we could do is do a long division. Their numbers x cubed, 2x squared minus 6x minus 9. And we could do a long division problem here. And say, when we do a long division, we're asking ourselves, what would we multiply that thing on the outside by to get the thing on the inside? So what would I multiply an x by to get an x cubed? An x squared. Then we multiply this by this. We get x cubed minus 2x squared. And then in long division, we subtract. So I get 4x squared and carry down the rest.
You don't want us to.
No. And then I could multiply now. What do I multiply by to get 4x squared? I would need a 4 and an x. Then I multiply by this, and I get 4x squared minus 8x And then when we learned long division, let me slide my screen, we learned we subtract that stuff. So that gives me 2x minus 9. Then what do I multiply x by to get a 2x? A 2. Take that, multiply 2x minus 4, subtract it, negative 5, that's our remainder over what we were dividing by, and we get the same solution. But it's a lot messier of a process.
Wow.
So this is called synthetic division because it's fake long division. It does the same thing as long division, but we've got that whole big messy blue side or the little purple side which takes 3 lines of paper, right? So synthetic division does long division for us, but it does it much more neatly. Okay. So let's do another example. So to do synthetic division, we start by setting up the same way we did for substitution. Highest power of x, count our way down. Write our coefficients. And off to the side, we put whatever would make the thing we're dividing by equal to 0, which is negative 3 in this example. Carry down, multiply, and then add down the columns. Multiply by the box, add down the column. Multiply by the box, add down the column. The solution to the division problem is a polynomial, so powers of x's is what polynomial means, starting with one lower power than the problem originally began. So it began at an x cubed, we're going to begin our answer at an x squared. Then an x, then a constant, and this one has a 0 remainder so we can ignore it. If that remainder was anything else, we would need to divide it by x plus 3, whatever the problem told us we were dividing by.
So you want to do x minus 3?
Nope, you do the actual thing you're dividing by.
Why
Should
should
go
the
on the
answer
bottom.
do you start with x squared?
Because in a division, we're taking something away from it, we're taking something out from it, so that power of x is getting lowered down.
Okay, so you just start, do you always start with x squared?
Always start with one less
Or
than you
just one
began.
less, okay.
Yep. Yep.
Is it x plus 3 what? Is there a reason or do you always do opposite? than
Yes. And the little box always goes the opposite of the division. Yep.
But
So
that doesn't apply for
not for substitution, because there you're told what x equals. In substitution it says substitute when x equals this number. So then you want to use that number. One more example, and this one has one extra step to do at the end of it. It says, given that f of 2 equals 0, find the other zeros, or another word for zeros is solutions. Okay? So we're given one solution to this equation, and we're asked to find all of the other solutions. The solution that we're given is 2. And we're told that when we plug a 2 in, we should get an answer of 0. So that's what we're going to do, is begin with synthetic. Write out our coefficients. Plug in the solution they gave us, which is 2. And we should get a final number remainder of 0, because it tells us that f of 2 equals 0, right? So we know that we made a mistake if we finish this thing out and we don't get a 0 at the end of it. Carry down the 1. Multiply gives 2. Add gives 0. Multiply gives 0. Add gives negative 9. Multiply gives negative 18. Add gives 0. We got a 0 at the end. That's a good thing. We should. They told us we should because it says f of 2 equals 0. When you plug in 2, you should get 0. Now we want to find all of the other solutions to this problem. according to division, if we began at x cubed in the original, we should begin at x squared here, plus 0x minus 9. Or our answer here is x squared minus 9. And we want to know where this thing equals 0. That's what it means by find the other zeros. We want to know where this equals 0. This is a quadratic equation. We just spent a whole long time learning how to solve quadratic equations in several different methods. Quadratic formula, factoring, taking square roots, lots of ways we learn to solve quadratic equations. We want to solve this thing now. I would solve it with square roots by adding 9 to both sides and taking a square root. And I get x equals positive and negative 3. And those are the other solutions to this equation then.
Well, what if you got negative 9?
Then we would have i's, and that's okay.
So it would just be 3i.
Positive and negative 3i. Yeah.
I'm supposed to get two zeros.
Yes, to the quadratic you should have 2 solutions. On your homework, 6.2. Just kind of, if you want to write some notes, what's going on in each of these problems. There's directions there, but just kind of help you out. These are just substitution. Okay, so that's where that last number is our answer in those first 3 problems. Okay, those are just substitution. The last number is our answer. This next group is review problems, gearing up for exams. This next group is division. That's where our answer is going to be the 1 lower power. And then in this last group, you do the division and then solve set equal to 0. Okay, so it's kind of progression through the problems. At first, we're just substituting. Then we're doing the division where we put in the powers of x. Then we're solving. Okay, so kind of each step brings in one additional thing, except for those review problems that are just kind of stuck there in the middle. Okay.